Hello. So let's get started. My talk will be about the Cloud-Cost, ClickHouse and OpenCost, how that's all married together. And we will start with a little bit of introduction. So my name is Kondratenko. I am working at Altinity as engineering manager for Altinity Cloud Platform. And yes, originally I'm from Ukraine, but right now I live in Nuremberg, Germany, where I moved to work for SUSE, where I was doing SAF development and management. And my past background is around the storage, Lustra, SAF, and etc. But recently I switched to the platform development. That was DBAS in Percona, and right now in Altinity, we are building the platform to manage ClickHouse for our customers and for you. And we also have open source project that helps with that, like ClickHouse Operator, which runs in the Kubernetes and manages the ClickHouse clusters. Okay, so why cloud cost? So first of all, economics, right? So as the business, we need to understand how much we spend on the cloud. And this is important for everyone. As well as we are building the SaaS solution, like we are managing ClickHouse and Kubernetes, so we need to actually bill our customers as well. So this is another reason that we need to understand what kind of costs we need to bill our customers as well. So there are our infrastructure costs as well as the customer usage, and et cetera, et cetera. So this is, for that we need also real-time data to show it both for customers and to us to actually detect some anomalies as well. And one of the applications for that is to submit this data to marketplaces. Usually when you sell through the marketplaces, you need to submit your usage quite often, like hourly or so, so the marketplace can bill this customer for you. So this all requires kind of real-time data as well. Whenever, and you can have other reasons why you would like to see costs, like if you are communities, you would want to manage your costs and see what kind of spend you have. Also, the environment footprint is really important, so you do not spend more and actually use more resources that you need. So you save, so reducing the carbon print. Cloud costs, what are those? So actually every cloud exposes some kind of interface. AWS, GCP, Azure, they give you possibility to see the cost in their UI, as well as to export them. But all of them are different. So AWS exposes it as the cost user report, for example, or you can upload those usages and costs to the Athena database and get it from there, like query, or maybe export it from Athena in some format or so. Also, GCP does it differently. They have a BigQuery to load your cloud cost, and then you can export it somewhere. Same for Azure. They support exporting to the blob storage, whatever you choose. So they all different, and this is a challenge. Another one is like how often they export those costs. And this differs from cloud to cloud. For example, AWS tries to do it like 3 times per day. The Azure is doing it daily, and GCP, I think it's hourly, but I'm not sure actually. We importing those costs like once in 6 hours. And it comes with delay because, yeah, they bill you for the hour, right, of usage. But they need some time to process all that and give you actual bill, because that could be some savings plan, there could be some discounts, and etc. All of that is reflected in those reports, but still it takes time. The only common thing among those clouds like AWS, Azure, GCP, and others are those that they use the CSV format. So all of this data you can export to the object bucket is usually in CSV. So you can then easily import that somewhere. The thing is about cost to remember that if you have a lot of resources and a lot of infrastructure, then you probably would like to tag your resources really well to actually figure out what team uses those resources or what tenant, what customer, whatever. So one approach is to tag their resources, and all of these reports from all of these vendors and customers, all of the clouds will have those tags. So you can identify the resources and pricing and usage by tags. So on this picture, you see what kind of challenge we have. It's Altinity Cloud, right? How we do it. We operate Kubernetes. So we have our main control plane, core Kubernetes control plane is the Kubernetes, as well as we manage the other customers' Kubernetes, right? So either under our account or under customer account. So that's, for example, you give us either permissions, like for project in GCP, or some access rules in AWS, and we provision resources under your account. Or you just connect any Kubernetes you want to us. So all of those are managed Kubernetes, either those managed by customers, or we prefer to actually roll the managed Kubernetes, either EKS, GKE, AKS. So we operate the Kubernetes. This shows like how we do it. It's like either like we provision it by our control plane, or you provision it yourself, and then we manage it from there. And as I said, this is what we do is ClickHouse. And on this slide, on this managed Kubernetes, we run ClickHouse database, and it's stateful, right? From one perspective, for cloud cost, it's a little bit easier because the load and databases are more or less static in terms of like, if you have like 10 replicas, 2 shards, that will be probably staying there and will not scale up, scale down too much. But from one perspective, it's easy because we don't have like kind of dynamic workloads. From other perspective, running stateful applications in Kubernetes, it's a different challenge. So we manage ClickHouse, and ClickHouse is the real-time database, real-time analytic database, which actually designed it to ingest a lot of data and analyze it really quickly. So it's used on all kinds of analytic applications to have snappy dashboards to analyze the logs, security logs. A lot of FinOps applications, etc., use ClickHouse to load it with the data, analyze it, and then proceed with the results. So it's also could be used as part of data warehouse, if you're familiar with those. And this one is scaling really well. It supports replication, sharding, all of the nice features. It's column-oriented and utilize resources really well. So this, if you allocate some resource to the ClickHouse database and ask it to proceed something, it will utilize everything on that node and whatnot. Another player in this picture, and most important one, is OpenCost. And when we came to the problem that we need to measure those costs, the OpenCost was already there, and it was an obvious solution for us as well. So OpenCost is the open source Kubernetes and cloud cost monitoring tool, not tool, sorry, solution. It's actually defines the specification and implements the specification for vendor neutral cost management and infrastructure cost management in Kubernetes. Here and there on this picture you can see that it actually gets its data. The Prometheus is required. It gets all of the data from the Prometheus about the containers, about the usage from a couple of sources. It's scoop state metrics, as well as from C-Advisor about all of the containers running, what kind of resources they consume. It's usually CPU, memory, if you have GPU, disks, all of that stuff it measures and reports back to Prometheus or other sources. Recently, I think it's from the past, in the last year, they added also cloud cost support. So you can measure not just usage, but also get the actual cloud costs. And as well is downloading the pricing from the cloud providers, like what resources cost what. For example, these instances, disks, etc., specifically for this class, what those costs, calculates all of that and gives you back as the result. Like, so the three main parts of OpenCost feature is the pricing, is the measuring of actual cost for the containers, so it looks into what kind of nodes it use, storage, and etc. And third one is it also can download the actual cloud cost. So it provides both real-time metrics about your usage based on pricing, as well as then later shows you actual usage that's actually a little bit behind. And KubeCost, that is upstream, that's actually vendor project, it's also can then reconcile those costs for you. And KubeCost also have neat features like analyzing the anomalies and alerting, which is really, really important. But OpenCost doesn't support it, so you need to build it yourself. And then you can get this data from either API that OpenCost provides, or it also exports these metrics to Prometheus. So you can scrape the OpenCost and it will provide you all the metrics about your containers, how much they consumed, what is the cost of was for this workload. In our case, it's a little bit simpler because there are few ClickHouse servers running there, and we have like tens of the servers like reporting that what costs for those, and usually they consume whole the node. In case of the smaller pods, there are some errors could happen, and there is the nice table in the OpenCost documentation, like what are those error could be, what are deltas, etc. So if you have smaller workloads, you probably need to check those, what kind of errors OpenCost could give you. Also, it exports to CSV, Parquet, and other formats, so you can check that out in the documentation. This is how, like, a simplified scheme how a tenant looks like. So it usually runs on the cloud, and there is the Kubernetes, whatever, it's EKS, AKS, we don't really care. And inside of it, we have two important parts. It's first of all ClickHouse, where there is ClickHouse operator that manage ClickHouse, as well as zookeepers. Zookeepers are needed to for replication between the ClickHouse over there. And this is what we actually observe, right? We also have observability stack deployed for each tenant, each customer, to troubleshoot issues, to actually monitor what is going on. We have logs, we have Prometheus over there, and obviously adding OpenStack there was easy. So it's kind of per customer, per tenant, per cluster OpenStack running over there and collecting the metrics about this particular cluster. Then it comes to us, right? All of this cloud data we collect to Victoria metrics. So all of the Prometheus, we run like hundreds of them, then we just push different ways. We push this data either by simple like remote rules from tenants that are under our account. They are pushed to the Victoria metrics and accumulate all of the data about all of the ClickHouse clusters over there and EKS clusters. So we have all of the data with special labels in our Victoria metrics where we can further analyze it. And this is kind of how we achieved multi-cluster solution. OpenCost by itself doesn't support multi-cluster for cost management. It's the feature of enterprise KubeCost. And we use OpenCost, we are using OpenCost just like an exporter, because we do not utilize so far. I mean, we probably will be expanding that, but so far we just utilize the exporter, OpenCost exporter, which measures the costs and pricing for the current cluster, and then we just accumulate all of the data in Victoria metrics where we can query it for real-time monitoring, but we do it a little bit different. So in our observability stack that we run on Core EKS, which get the data from all of the tenants, hundreds of the clusters, and as well as about our control plane and Core EKS, then we push most of this data to ClickHouse, to our billing database. And also we get the data from each cloud about the spend cost. So we kind of have real-time data from OpenCost as well as the data about the actual cost from the cloud. And how we do that? So we just utilize ETL pipeline and push everything from the AWS core report, like we configured that to be on S3, GCP, BigQuery, we exporting this data to the GC for Google Cloud Object Storage, Azure for Blob, and we also need kind of real-time metrics as well. So we push some of the Victoria metrics from the database, from the time series database to the ClickHouse. So ClickHouse is kind of center of our billing. We upload all of the data about all of the tenant as well as our infrastructure in the ClickHouse, which is the ClickHouse is quite suitable for that. It's actually was designed, it's actually designed for such kind of applications where you have ETL pipelines pushing all of the raw data, because all of this data in these reports, they have different format, schemas, and etc. We push it raw there, and then we just start to create with features of ClickHouse, we create different views, material views, and etc. to, first of all, show it on our Grafana dashboards, like what is the cost for this customer, for that customer, what a cost for our infrastructure, what's like the margin over there, and etc. etc. We get this all from ClickHouse through the Grafana, as well as we have a user UI which provide the information to the customer, like what is your current bill, what is your projections, what is your real-time spend. And it's also solved our solving our marketplace offering, because like the cloud cost, before this approach, cloud cost will come later, and cloud cost mostly suitable for monthly billing. So you kind of see the data later in the time. When with OpenCost and all of the monitoring data, we can bill customer per usage, like per hourly. So that's what we do, and this is really suitable for marketplaces. Like if you are listed on AWS, GCP, or other marketplaces, you probably need to submit that usage quite regularly. ClickHouse provides you really nice features. First of all, it's SQL, so you don't need anything else there. We we do all of the mathematics about the billing and all of the aggregation with these simple features. Like, first of all, we can upload data directly from S3, right? So we don't need, sometimes we even don't need the special ETL application to get this data to ClickHouse. We can just upload it from ClickHouse directly, reducing the number of development we need. Second of all, aggregating all of this data into something that could be used by application, UI, or Grafana. We use like both material and as well as simple general views, which either store it on memory or just store it on disk. And aggregating it, we actually have usable information that has same format, right? That's like, this is a line item, this is compute cost, storage cost, object cost, etc., etc., etc. So all of that needs little application development, if at all. So most of it you can just do with the awesome ClickHouse features itself. Challenges. So all of this tech when we implemented it, and we kind of knew these challenges before, but they appeared to be more pronounced. First of all, network cost. Right now, OpenCost it's kind of support ingress and egress cost, but we do not use that. We use load balancer, our own proxy, and if you have a complicated network state, then you might have a problem with kind of define who ate those network resources. And it's not like you can, based on monitoring data, you can figure out which pod consumed what network resources. But the problem appears in the cloud that it could be cross-zonal, for example. And then you have interzonal traffic there, which you need to figure out who actually does that, who consumed this traffic in a big environment with a lot of connections, like client connection to ClickHouse, ClickHouse to Zookeeper. It's really challenging to figure out what those interzone traffic is, and like who is the consumer and how to optimize it. That's one of the challenge we found out. And another one is object storage. The ClickHouse can we do backups of the data, customer data in S3 or cloud on object storage, and that is kind of not supported currently. So it's you cannot measure your object storage cost, and those could be quite extensive because it's backups, like terabytes of the backup data. Plus, additionally to that, it's not only the data or size, it's also API calls, how often you do that. And that's kind of a problem, especially for anomaly detection. If you have a lot of data and you forgot to delete your backup, you immediately see the bill increase, like petabytes of data. You forgot to actually delete it, and that's a problem. That's a problem where actually this cost management and analytics could help you, but not yet. There is a useful link. OpenCost is an awesome project. I learned a lot from Go code. They really nice. If you're curious about the monitoring, this is the way to go. And there is Altinity projects open source. It's a couple of them, Operator, and we also manage data source for Grafana plugin. It's also open source, and we use it extensively to visualize the data. Thank you. Any questions?
Thank you, Denis. We have a couple of questions. Let me bring them up. So the first question is, and let's see. You said that you run ClickHouse with Zookeeper. Why do you prefer Zookeeper over Keeper?
Yes, so ClickHouse has the Keeper project, and we currently adding the Keeper support to ClickHouse Operator. It was already a beta phase for it in the ClickHouse Operator. But so far, we haven't tested ClickHouse Keeper in good extent to graded to production. And also, I think in the future, like in the near future, we'll be switching to that, but new customers. And yes, this is a future for us because like ClickHouse can drop Zookeeper support in any time, and Keeper is the way to go. It's a little bit simplified for this use case. So it's coming, but it's still not like a production grade for us. Like
Perfect. Another question is about, is this for Kubernetes workloads, or can I use it for only major clouds, or what can I use it with?
ClickHouse, so like it's for everything. It's like general real-time analytic database. OpenCost you can use for only for Kubernetes and clouds. So it imports your, like it shows your spans on Kubernetes for first and foremost, but also cloud resources as well. So ClickHouse is a general real-time analytic database, not general, but like data warehouse database. You can use it for everything. We just choose to run it in Kubernetes because it's easier for us and we manage it there.
Perfect. What type of customer data are you backing up at day 0 Kubernetes? What is your Kubernetes setup at the day 1, including your customer workloads? So I guess it means that if you also back up the customer workloads at day 1 or the setup of the Kubernetes cluster itself, and what kind of tools are you using for that?
So we tried different infrastructure as a code solutions, like Ansible for GCP. Right now, using it a little bit, Terraform for everything, EKS and other resources. But we realized in time that we need to build our custom platform. So it's like a Go code written platform to provision any cloud resources. So it supports all of them. That's like our backend, it's our control plane that reconciles the infrastructure. And day 0, so we choose to use managed cluster. So we provision some managed cluster for you. If you are not bringing your own, you can bring your own. Then we just have a connection to your Kubernetes cluster. But we provision everything. We updated the cluster, the managed cluster. So it's still, you need to still roll those updates, etc. We manage node pools, we have autoscaler, so we have do everything that you do not notice that you have Kubernetes inside. So you just have your ClickHouse database, and that's what and UI interface for it. Yeah.
Thanks. We have a little bit of time for last question. I think this was mentioned, but let's repeat it as well. So where and how do you store data from ClickHouse on Kubernetes?
Yeah.
And what do you use as your data storage?
Yeah, so I had a talk last year, I think, or no, early this year. I don't remember, about like how ClickHouse stores the data. We use GP3 volumes on EKS or just regular volumes on GCP. ClickHouse is not so dependent on I/O. Right? If you're hitting it with a lot of data, it even can read and write from the object storage. So like from this perspective, like if we take EKS, we just store it on the, like in PVCs that we manage, and that's all. So it's just regular storage. And then we can resize those PVC, add more disks to the ClickHouse server, managing its configuration, etc., etc.
Perfect. That was our last question.
Okay.
Thank you very much.
Thank you, and feel free to approach me and ask more questions. Yeah, I will be around. Thank you.